Welcome to Space Tech Insider.
Imagine launching an arrow into the sky, but instead of just flying, it needs to hit a tiny target hundreds of miles away, moving incredibly fast. How do engineers make sure something as powerful as a rocket stays on its precise path? That is an amazing feat of engineering, isn't it? A rocket's path is primarily controlled by its guidance and navigation system, working together with its thrust vector control. This combination precisely adjusts the direction and magnitude of the engine's thrust to steer the rocket toward its intended destination. The core mechanism behind this control involves a continuous feedback loop. Onboard computers constantly compare the rocket's actual position and trajectory with its planned flight path. These computers use data from sophisticated sensors, including inertial measurement units, or IMUs, which track orientation and acceleration, and sometimes global positioning system, receivers for external position updates. When the rocket drifts even slightly off course, the computers calculate the necessary correction. This correction is then executed by gimbaled engines, which can pivot their nozzles slightly, or by small steering thrusters, to change the direction of the exhaust gases and, consequently, the rocket's direction. This constant fine-tuning happens many times per second. To put this into practice, engineers first define an incredibly detailed flight plan, which is essentially a three-dimensional map for the rocket. During flight, if the guidance system detects a deviation, it sends commands to the actuators connected to the rocket's engines. These actuators physically move the engine nozzles, reorienting the thrust. Think of it like steering a boat by changing the direction of its propeller, but much faster and more precisely. For example, if a rocket needs to pitch up, the engines can tilt slightly downwards. Similarly, yaw and roll movements are controlled by differential thrust or by using multiple engines. One fascinating aspect of this control is the concept of gravity turn maneuvers. Instead of performing large, power-intensive steering corrections, rockets often use Earth's gravity to their advantage. After a short initial vertical ascent, they gradually tilt horizontally, allowing gravity to naturally curve their trajectory into orbit while the engines provide forward thrust. This conserves a tremendous amount of fuel, making launches much more efficient. Another insider detail is the importance of reaction control systems, or RCS. These are small thrusters, often using monopropellants, that provide fine adjustments for orientation, especially after the main engines shut off or in the vacuum of space where gimbaling main engines is not efficient for small changes. Understanding how a rocket's path is controlled reveals a brilliant synergy of advanced sensors, powerful computing, and mechanical precision. This intricate ballet of physics and engineering not only ensures rockets reach their exact targets, whether it is an orbital insertion or a deep space probe, but also optimizes fuel usage and mission success. It is a testament to human ingenuity, making space travel predictable and reliable for everything from satellite deployment to sending astronauts for beyond our home planet.
Join us at Space Tech Insider, where innovation meets the infinite. Discover the future today.